Suppose an experiment is done with criminals released from prison in a certain state where the recidivism rate is 33%. It goes on to say 100 random prisoners are made to attend a boot camp for 2 weeks before their release, and it is hoped that this boot camp will have a good effect. It goes on to say now that suppose 29 of these 100 prisoners return to prison within 3 years. Part A says, what is p hat, the sample proportion? So this is the value that you get from your sample. If 29 out of the 100 prisoners return, the number that goes here is going to be 29 divided by 100, which is 0.29. So p hat is the value that you actually get from your sample. And now we're comparing this to p naught, the hypothetical proportion, which is 33%. Now that's what goes here. I'm going to put it as a decimal, so 0.33. And I'm noticing that, well, the value p hat from the sample is less than the hypothetical value p naught, and part C is asking for the test statistic. This measures how much lower this value is from this one in terms of standard deviations. Now there are formulas for this that we could use, but you can also use StatCrunch, so I'm going to do that. If you go to Question Help and choose StatCrunch, we want to choose a calculator that will do a hypothesis test for us. So let me show you where that is. If you go to Stat and go to where it says Proportion Stats, this question is asking us about proportions. I want to choose one sample because there was a sample of 100 prisoners. That's just one entire sample. And this was summarized for us. They said 29 of the 100, so that is a summary. And if you select those things, it opens up this. I'll first enter in what we're going to call the successes, which is the 29 out of the total 100 prisoners. And since we're doing a hypothesis test, I want to make sure that this is selected here. The value that goes in place of p is going to be this hypothetical value, this 33%. So I'll put in 0.33. And for the alternative hypothesis, there's 3 options. You can do not equal, less than, or greater than. And you have to somehow figure this out, from the question itself. And I'm seeing that, we're hoping that this boot camp will have a good effect on the recidivism rate, which means we're hoping that it lowers it. So it kind of is implied that, well, I want the alternative hypothesis to be less than. All right, with all that being said, I'll click Compute, and here we go. This gives us a lot of important information. It tells you what you entered, the sample proportion, which it gets from those 2 values, but it also gives you the standard error and this thing over here, which is the z-stat. This is the test statistic that we're looking for here. If I round that to 2 decimal places, that's negative 0.85. I'll check my answer. Okay, so this is telling me how many standard deviations away this value is from this one. It's negative because this is less than this, and that's not even a full standard deviation away. So let's enter those ideas in here. So it says, the value of the test statistic tells that the observed proportion of prisoners was, well, I think I'm going to leave it as a positive value here, just kind of looking ahead with the spaces that we have. It was 0.85 standard deviations, and it's going to ask me to select either above or below, and I'm going to choose below. The reason that I left this as positive 0.85 is because the language below is implying the negative. So it's this is the absolute value of this number, and then this language tells you, oh, well, we're to the left instead of the right. So let's just read the sentence, make sure it makes sense. The value of the test statistic tells that the observed proportion of prisoners was 0.85 standard errors below the null hypothesis proportion. So that seems to make sense, and I'll check my answer. Okay, that's it for this problem.